And if you could just give me one of your most important breakthroughs that R&D on electrolysers has to achieve to expand the application or reduce costs, whether this be catalysts, membranes, stack design, or just the scale of production. Dave, I'll come to you first on that one.
I'd answer in two parts there, if you guys don't mind. So I think there's we look at the existing electrolyser technology, a big breakthrough, and I think it's probably unachievable, by the way, in terms of reducing the cell voltage, would be if we could change the performance of the anode catalyst. That's got oxygen evolution is a well-known slow electrochemical reaction, which leads to a high overpotential, which leads to high volts and leads to high energy costs right now. So if there was something on there, that would probably be a breakthrough. We've probably got about 50 millivolts overpotential on the platinum cathode, and we've probably got a few hundred millivolts overpotential on the anode. And that shows the big difference and the challenge that's in there. But there's been many electrochemical processes where oxygen has been evolved over the years, and nobody's really shifted that too much. The other thing, though, is, well, what about a wholesale shift? If you look forward 20 years, what do we need? Again, European Hydrogen Week last week, a lot of discussion about the potential for thermochemical processes to be able to do something different there, where you can split water with concentrated light, sunlight, for instance. Now, these operate 900 degrees or so. The thermodynamics are quite different, and you can get reduced energy consumption as a result. But they are going to need a lot of work. Imagine how long it's taken us to get to this point with the existing technologies. There's a lot of investment to be gone into those. So I'd split it. There's something interesting in the current materials, but really difficult the current technologies. But downstream, in time, we might be looking at something completely different in the 2050s, 60s, 70s.
Thanks for that, Dave, and we'll afford you the two-part answer there. Daniel, how about you? What's your most important breakthrough that R&D on electrolysers has to achieve?
Yeah, I think we have to increase the power density on the electrolysers. This is a big leverage, especially with PEM, which I think is underestimated. Where in laboratory conditions you already have about 3 to 6 times power density what we see in the field right now, and the data on this are good, promising, but it's still early R&D stage. But if this comes to market, it will reduce the cost per kilowatt drastically, even for PEM. It maybe even could surpass the alkaline development that we have right now. So this is for me the most important thing, besides getting rid of iridium oxide in some way, or at least reduce it to a minimum. But also here I see the developments on the membrane side, which are highly promising. It's not my area of expertise in depth, but I've seen some laboratory data on loadings and so on, and this goes in the right direction. So I would not be too worried about the big questions that always come up, especially catalyst problems. This will be solved, in my opinion, in the next, let's say, 5 to 10 years.
Great, thank you for that, Daniel. And to open that to you, Paul, what would be your take?
Short and simple, I'd say stack costs. Here again, that's going to be your primary long-term ON operation and maintenance costs. So the better job we can do on driving down the stack costs, both on the new build and on the aftermarket, that's going to keep the overall cost of hydrogen lower.
Sure, and to complete this round-robin answer, Yuki?
Definitely not a tech expert, but from what the Chinese market, based on what the market is talking about for the alkaline, I think there is like a 10 to 20% space still for price reduction for alkaline. And then the focus would be to improving some of the technology of electron and the membrane production locally in China. And then for PEM, I think I would have to go with all the expert today here on the chemistry, the catalysts for the chemical reaction. I think that's the key.